Hello. Today we're going to talk about memory handling of primitive types and object types in Java. So I've drawn a representation of the computer's memory, the stack and the heap, and we're going to take a couple liberties to make tracing easier. For example, in a stack we start off at the top and go up to the bottom. For our purposes we're going to start at the top and go to the bottom to make it easier to trace. So let's look at line 5, see what's going on. We're declaring a new variable of type int, a. So we're going to say a equals, and then the value is 3. Now since int is a primitive type, all of the data is going to be stored on the stack, both the variable and the data inside it. So next we're going to declare a new variable b, and we're going to initialize it as the value of a. Since b is a primitive type, when we set one primitive type equal to another, it copies the data. So it makes a copy of the data in a and puts it in b. Now, this is important because a and b are not connected. They each have their own value, number 3. Okay, so we look at line 7, we're changing b equal to 100. So we're just overwriting that 3 with 100. And again, there's no connection to a. These are their own discrete entities. Okay, let's look at line 9 now. We're creating an int array. Now, an int array is an object type. So we're making C. Now, as an object type, most of it is stored in the heap. The only thing that's stored in the stack is a pointer to the memory location on the heap that actually has the data. So let's create the object in the heap, and the object is going to contain 4 values. It's an int array of size 4, 1, 2, 3, 4. Now the data that is on the stack is simply the pointer to this memory location. So now next we're creating another int array d. So we say d equals, and what we're saying is equals c. So what it's doing is it's not copying the data in the heap, it's copying the data in the stack that's attached to c. And the data in the stack that's attached to c is the pointer, this memory location. So now c and d are both pointing to the same memory location. Now why does this matter? Well, on line 11 what we're doing is we're reaching into the heap, and we're reaching into this piece of data, and we are changing what's in index 1. So we're setting index 1 to 99, so we're overwriting this value. Now this ends up having an effect on both C and D. Because since C and D are pointing to the same object in memory, now C index 1 is 99, and D index 1 is 99. Okay, let's look at how we could handle int arrays a little differently. So we're creating 2 new int arrays, E and F. So we say E equals new object. This object contains the number 5, 6, 7, 8. It's also an array of size 4. And the value of E in the stack is a memory location that points to this new object. And then we say we're declaring another new int array, F, and we are creating a second new object that happens to have the same values, 5, 6, 7, and 8. Now, these, even though these have the same values, these arrays are equivalent to each other. They are stored in different memory locations. So E is pointing to this memory location, F is pointing to that memory location. So when we reach into the object that F is pointing to and change index 1 to 98, we are only affecting the F, because E is pointing to a completely different object. Okay, let's look at strings. Now strings are what we call immutable. So these objects, we've been able to reach in and make changes. We can't do this with strings. So let's see how this affects us. Okay, we're going to start by creating a string G, and string is an object type. So we're creating a pointer, and then we are pointing to, we created a new object which has the string hello in it. Okay, then we said string h, so we're making another variable, and we are copying the pointer from G. So now these are pointing to the same memory location, just like what was happening with the arrays. Now, we can't reach in and change what's in this memory location. So we actually, if we want to change this, we need to actually create a new object. So we're saying h equals goodbye. So this is creating a new object, and this does something important. We create a new object, goodbye, and we change the pointer of h to this new object. So now G is still pointing to hello, and H is still pointing to goodbye. So G and H are no longer connected because we created a new object and changed where H was pointing. Now we could have made a new object and had E or F or whatever point to a new object, but instead we chose to reach in and make changes to the existing object. In case of strings, we can't reach in. These are immutable, these are unchangeable. So if we want to change the value that's assigned to the variable, we simply have to create a new object and move the pointer to that object. So this is a basic explanation of how primitive and object types are handled in memory. If you check the next video, we're going to learn about how this affects checking equality of both primitive and object types.